Okay, we're going to go ahead and talk about our second method of solving a system. And last time I talked about how we are going to have two different algebraic methods. This is our first algebraic method, which is really good for if your numbers are big and don't fit on the graph, or if your answers end up having decimals or fractions as answers. So this method is called the substitution method because we're going to replace things with what they're equal to. And what you need for this method is you need to have one of your equations looking like this, where it says y all by itself is equal to a bunch of other stuff. Or you have to have something that looks like this, x equals something that's all some gobbledygook, whatever stuff there. So we need either the x all by itself on one side of the equal sign or the y all by itself on one side of the equal sign. And so when we're looking at this information, we're going to take a look at our system and we're going to figure out what is it equal to. And then I'm going to go into another equation and I'm going to replace that letter with the gobbledygook that's after it. And so it makes a lot more sense when I point it out to you. So we're going to go ahead and we're going to look at our first equation. We have our system. We have 2x plus y equals 5. And then we have x equals y plus 4. And so the first thing we're going to do is we're going to look for which one's by itself. Do I have a y equals or do I have an x equals? And when I look at this, right here I have an x equals. Which means that up here, instead of this x, I'm going to put what x is equal to. So I have to figure out what is x equal to. So I go back to that first equation. It says x is equal to y plus 4. So I'm going to put that highlighted portion right here. So how is this going to look? It's going to look like 2, and then I hit that highlighted portion. I'm going to take that highlighted portion, I'm going to put it where that x was. So now we get that highlighted portion of y plus 4 plus y equals 5. And so I want to just take a minute here and show you that this right here, hold on, need a bigger highlighter, there we go, is this equation right here. So I have 2 highlighted plus y equals 5, and that's what we have, 2 highlighted plus y equals 5. And that's exactly what we did. I took this highlighted portion, y plus 4, and I slapped it in where there was an x, because that's what it's equal to. That's the whole idea of substitution. If it said x equals 4, then I would put a 4 in the x spot. But it doesn't. It says x equals y plus 4. And this is where we get the more complicated type of math, which is why it was really important to know how to solve equations. Because now we have to solve this equation, which we can do because now we only have one variable. We have y. And so we can use our methods to go ahead and solve this. So we're going to go ahead and we're going to solve this. The first thing we do to solve it is get rid of those parentheses. So 2 times y, 2 times 4. So now I have 2y plus 2 times 4 is 8 plus 1y equals 5. Now in my equation now, I have a 2y and a 1y and they're on the same side. So I combine them. 2y plus 1y becomes 3y. So now I have 3y plus 8 equals 5. And now I can solve this equation. I move the 8 to the other side by minusing, because that turns this to 0. So now I have 3y equals, and 5 minus 8 is negative 3. I divide by 3 on both sides, and I get a y value of negative 1. And that is part of my solution, because remember, I'm looking at where these lines intersect. So this is the y value of where my lines intersect. Now this is called substitution for a reason. And now we're going to substitute again. So I know that y is equal to negative 1. So I can come up here to any of my equations and I can plug in negative 1 for y, and that'll allow me to solve for x. So I'm going to go back up to here. And so that equation is x equals y plus 4. Well, I knew that y was that negative 1, so I'm replacing y with that negative 1. So x equals negative 1 plus 4, which tells me that x is equal to 3. So now I have the pieces to my solution. What is the solution? These lines intersect at the point 3, negative 1. Because remember, this is a coordinate with an x value first and a y value second. and that is our solution. And so this is probably the most complicated method, but it is the most useful method. We use it all the time in geometry, algebra 2, pre-calc, calculus. The substitution method is probably the most used method because it's just set up so easily in most situations that we come into. So let's look at another problem. So now I have y equals negative x plus 3 and x plus 4y equals 6. So now I have to ask myself, do I have an x equals or do I have a y equals? So I see that I have a y equals, so I'm going to circle my y here. I'm going to circle my y here. And now I have to figure out, well, what does y actually equal? So here I know y is negative x plus 3 because it says y equals negative x plus 3. So I'm going to put that where there's a y in this equation. So now I'm going to go ahead and work this out. So I'm going to rewrite this equation. So x plus 4, and now I get to that highlighted portion. So now I'm going to put the highlighted portion in, negative x plus 3. And then I'm going to keep writing that equation, equals 6. Now I'm set up. I can solve this equation. So the first thing I'm going to do is I'm going to distribute the 4 inside. Looks like my marker went a little crazy there. So now I have this 1x plus 4 times negative x is negative 4x. 4 times 3 is 12. And now I'm going to combine my like terms. So 1x plus negative 4x combines to become a negative 3x. So this is negative 3x plus 12 equals 6. I move the 12 to the other side. So now I have negative 3x equals negative 6 minus 12, which is negative 6. Now I get rid of the negative 3 by dividing, because those are side by side. That indicates multiplication. So the 3's cancel, the negatives cancel, so I have just x. And on this side, my negatives cancel, and 6 divided by 3 gives me 2. A lot of work for my first answer, but once I'm here, I'm pretty much almost there to my final answer. So now I have to figure out, if I know x is equal to 2, what is y? So I'm going to go back to this original equation here, and I'm going to plug that in. So now I have, let's see, that original equation was y equals negative x plus 3. Well, I know x is 2, so in this spot I'm going to put the number 2. So y equals negative, and then I put the 2 in, plus 3. So y is negative 2 plus 3, or backwards, 3 minus 2. Positive 1. So my solution, x comma y, because remember this is a point on the graph, is 2, 1. And that is our answer. Okay, so let's go try another, because the more you see it and the more you actually go through the process, the easier this gets. Okay, so y equals or x equals? Well, we have a y equals. So circle my y's. And now I have to figure out what is y equal to. So I'm going to look, y is 2x plus 8. So in this y spot, I'm going to put that 2x plus 8. So now I'm going to go ahead. This is 3x plus 2. Now I'm going to put in the highlighted portion, 2x plus 8. And then I'm going to finish the equation, equals 9. So this is really just being rewritten there with the highlighted portion in for y. So now I'm going to go ahead and get rid of my parentheses, so I'm going to distribute in the 2. So now I have 3x plus 2 times 2x is 4x, 2 times 8 is 16, equals 9. So now I have a 3x plus a 4x, which is 7x. Now remember they're on the same side, so I'm just combining. And now I go ahead and solve. So I move everything away from the x, starting with the plus 16, so I'm minus 16 on both sides. So now I have 7x equals 9 minus 16 is negative 7. I divide by 7 on both sides, and x equals negative 1. Okay, so I have half my answer. I still have to go plug it back in. So now I'm going to go ahead and use my original y equals. So y is 2x plus 8. And in that x spot, I'm going to put my value. So y equals 2 times negative 1 plus 8. 2 times negative 1 is negative 2. And then negative 2 plus 8 is really the same thing as 8 minus 2, which is 6. Oops, that's not my final answer. Because, remember, these are two lines intersecting, so I have to actually label the point. My x value of my point is negative 1. The y value of my point is 6. Okay, let's try another. So now we're looking for x equals or y equals, and it looks like this time we have an x equals, so I circle my x's. Okay, what is my x equal to? So I'm going to go ahead and go back. X is equal to 4y plus 11. So I put that highlighted portion right where that x is, and I'm going to go ahead and work on rewriting this. So this equation, whoops, sorry about that. This equation is going to be rewritten 4y minus 5, and in that highlighted portion we're going to put, oops, 4y plus 11. Now I'm done with the highlighted portion and I finish writing my equation, equals 9. Now to solve, I get rid of the parentheses by multiplying. So I'm going to multiply by negative 5 here because that's a minus 5, so multiply negative 5. So this is 4y. Negative 5 times positive 4 is negative 20y. Negative 5 times 11 is negative 55. And that is equal to 9. Now I have to combine my like terms. They're on the same side. So 4y minus 20y becomes negative 16y minus 55 equals 9. Now I move everything away from the y, starting with the minus 55. So I'm going to add 55 to both sides. So now I have negative 16y equals, and 9 plus 55 is 64. Now I divide by the negative 16 on both sides. So the 16s cancel, the negatives cancel, and y equals negative 4. So now I have my y value. I'm halfway there. I still have to find the x value. So I'm going to go back to my original x equals equation. Normally, just because that one's easier, I could use the other equation if I wanted to. So x equals 4y plus 11. And since I know y is negative 4, I'm going to rewrite it with, instead of y, negative 4. So now 4 times negative 4 is negative 16. And then negative 16 plus 11, or 11 minus 16, is negative 5. So now remember, these are two lines intersecting. So I have to label the point where they intersect. And my point has an x value of negative 5 and a y value of negative 4. So that is my solution. Okay, next equation. This one looks a little different because both of them are y equals. So you get to decide which one you start with. I like starting with the top one just because it is up there on top. So I have a y equals. So I'm going to circle my other y. Then I'm going to highlight what y is equal to. So y is equal to 2x, which means in my other equation, I'm going to put the 2x right here. So now I rewrite this equation. So instead of the y, I'm going to put the highlighted portion. So now this is 2x equals x plus 5. And this time my x's are on different sides. So I have to add or subtract to move one over. I'm going to go ahead and move this x, so I'm going to minus 1x on both sides. So x minus 1x becomes 0. 2x minus 1x becomes 1x, or x. So x is equal to 5. So actually this one seemed to be simpler than my previous problems. But I only have half my answer. So now I have to go back to one of my equations. I'm going to go ahead and use the top one. I have y equals 2x. Since I know x is 5, I'm going to substitute. So 2 times 5, so y is 10. And now remember, there's two lines that intersect, so I want to know where do they intersect. They intersect at the point 5, 10. And that is my solution. So we're going to go ahead and look at another one. Because again, the more examples, the more you go through it, the more comfortable you feel. So, it looks like I have two y equals, so I'm going to circle both y's. I get to decide which one I start with. I'm going to go ahead and start with the top one. So y equals x plus 3. Whoopsie. I meant to go to highlighter. So y equals x plus 3. So I'm going to put this in the other equation where there's y. So I'm going to put it right there. So now I'm going to go ahead and here I'm going to rewrite this. So in the highlighted portion I'm going to put x plus 3, because that's what's highlighted, equals 2x plus 5. Now this time again, my x's are on different sides, so I have to subtract from both sides or add to both sides to get them on the same side. So I'm going to move this x, so I'm going to minus 1x on both sides. So that turns into 0. So now I have 3 equals. Okay, so now we have the 3 left on that side, and then 2x minus 1x gives me 1x. And then we bring down the plus 5. And now I move everything away from the x, starting with the plus 5, so I'm minus 5 on both sides. And now I have 3 minus 5, which gives me negative 2, is equal to 1x, but luckily 1x is the same thing as x, so now we have our x solution. So now we can go back to one of our original equations, and it doesn't matter which, but I'm going to go ahead and use the first one because it looks easier. And we have y equals x plus 3. And so now y equals x, which is negative 2 plus 3, and negative 2 plus 3 is the same thing as 3 minus 2, which gives us 1. And so remember, these are two lines intersecting, and so our solution is x comma y, and that is the point where the two lines intersect. Okay, let's see. So now again, we have 2y equals, wait, did we already do this one? 2x, x plus 5? Hey, we already did this one. Yay, we don't have to do it again. Okay, so now we're moving on to word problems. And so this is where we start getting types of problems that tend to show up on SAT, ACT, AMP, all that sort of stuff. And they tend to be simpler problems, but sometimes they're more complicated problems depending on the setup. So we're going to talk specifically about age problems right now. And so we have Kim, and she is 6 years older than 3 times the age of Dan. So the first thing I probably want to do is say that K is going to stand for Kim, and D is going to stand for Dan. So I know Kim is, and is a key word for equal, so Kim is 6 years older, so I'm going to add 6 years to 3 times the age of Dan. So I'm going to multiply 3 times the age of Dan. And so this gives me an equation to start with for the first sentence. Now, we're also going to talk about 8 years ago. So every time we're dealing with Kim and Dan, we're going to go ahead and talk about Kim and Dan as in 8 years ago. So Kim's age 8 years ago was 2 years less, so I'm subtracting 2 years from 9 times Dan's age. So 9 times Dan's age, but Dan's age was 8 years ago. Which looks really crazy. But we can handle this because my first equation has an K equals. So down here, instead of K, I'm going to put down what K equals. So I'm going to go to my highlighter. K is equal to 6 plus 3D. So I'm going to put 6 plus 3D right here. And so now I'm going to go ahead and work this out. So in the highlighted spot, I'm going to put 6 plus 3D minus 8 equals 9 times D minus 8 minus 2. And so I've got a lot going on here, so I'm going to go ahead and try and simplify this a little bit. I'm going to go ahead and combine my like terms. So 6 minus 8 is really negative 2, so this is 3D minus 2. And on this side, I need to distribute that 9 inside. So now I get 9D minus 72, and then minus another 2. And then I'm going to combine those. So now I have 3D minus 2 equals 9D minus 74. So now I've got my equation, I've got d's on different sides, so I'm going to move my smaller d. So I'm going to minus 3d on both sides. And so now I have negative 2 equals 6d minus 74. And then I'm going to add 74 to both sides. And so now I have 72 equals 6d. I divide by 6 on both sides. And d is equal to, let's see, goes in 10, gives me 60 plus another 2 more. So d is 12, which means Dan is 12 years old. But now I still have to figure out how old Kim is. So I'm going to go back to Kim in purple. So Kim is 6 more than 3 times Dan's age. And since Dan is 12, we're going to say Kim is 6 plus, and then I do multiplication first by order of operations. So 3 times 12 is 36. And then 6 plus 36 gives me 42. So Kim is 42. And Dan is 12. Okay, so let's try another one of those. A little different. The sum of 3 times Mike's age and 2 times Jill's age is 54. So sum means I'm going to add up. So I'm going to add 3 times Mike's age, and I'm adding 2 times Jill's age. And that is, so that's our keyword for equals, 54. Now, we also know that Jill is, so Jill is means equals 8 years less, so I'm subtracting 8 years, then twice the age of Mike. So 2 times Mike's age. So now I'd go back and I'd figure out, okay, which one is by itself? So I have a J by itself right here. So up here in the J spot, I'm going to put what J is equal to. So let's figure out what is J equal to. Well, J is equal to 2m minus 8. So here in the J spot, we're going to put 2m minus 8. So now I'm going to go back to that original equation right here, and I'm going to rewrite it. So 3m plus 2j, but instead of the j, I'm going to put the highlighted portion. 2m minus 8, and that should be equal to 54. So again, just rewriting this equation down here with that 2m minus 8 in the highlighted spot. First thing, I distribute the 2. So now I have 3m plus 4m minus 16 equals 54. My m's are on the same side, so 3m plus 4m gives me 7m minus 16 equals 54. I add 16 to both sides. So 7m equals 70. So m would equal 10, because if I divide by 7 on both sides. So now we know Mike is 10 years old. Now we have to figure out how old Jill is. So I'm going to go back to that green equation where Jill is 2 times Mike's age, 10 minus 8. So Jill is, I multiply first, 2 times 10 is 20, minus 8, and 20 minus 8 gives me 12. So Mike is 10 and Jill is 12. And that's it for our substitution method. We'll talk about a third method in 5.3.